All right, let's go ahead and take a peek at this here. We are in the 4th grade textbook. We are looking at chapter 6 and exercise 5 in the workbook. This is page 141. So let's see what we're being asked to do. It says express each improper fraction as a mixed number in simplest form. So the first thing that they have done is they have gone ahead and they had broken apart 18 over 4 in A. They have broken it apart into 16 over 4 plus 2 over 4. So basically what they've done is they've taken 18 over 4 and they've realized that 4 over 4 would be equal to 1 whole. Could we have gone ahead and created a number bond where we were just slowly subtracting every possible whole that we could? Yes, definitely. So they basically said 16 over 4 would be the same as 1 whole, 2 wholes, 3 wholes, 4 wholes, and you would be left with a 2 over 4. And I'm just going to rewrite that down here. 1, 2, 3, 4. And 2/4. Now, they're asking for simplest form, so what we're asking for here is a simplified fraction. So we're going to go ahead and we're going to make sure that we are simplifying 2 over 4. Now, we want to make this as small as possible, and in order to do that, we want to find something that can divide evenly into both 2 and 4 because we're trying to find the smallest fraction, fractional numbers, simplified fraction that we can. Well, I know that 1 and 2 are 2 factors of 2. And if I wanted to write that out in a T-chart, I totally could. 1 and 2 are the 2 factors of 2. And the factors of 4 are 1, 4, and 2. A matching factor here would be 1 and also 2. Dividing by 1 would not be beneficial here, but 2, yes, we can do. We're going to divide by 2 so that we can end up with our simplest form fraction. 2 divided by 2 is 1, and 4 divided by 2 is 2. So our simplified fraction, or mixed number written in simplest form, would be 4 wholes and 1/2. Let's go ahead and look at the next one. Over here on C, for instance, we'll head down to C because it has less support here. 16 over 7, we could go ahead and say, how many times can we count by 7s to find out how many wholes we can pull from 16 over 7? 7, 14. If I pulled out 14 sevenths, I would have been pulling out 2. How do I know that? Because I counted by 7s 2 times until I got to 14. What would be left? Well, if I had 16 sevenths and I were pulling 14 sevenths away from them, I am left with 2 sevenths. So this is really similar to a number bond here. So now we can turn this into the next stage. We're going to take 14 sevenths and we are going to rewrite it as whatever whole this represents. 7 over 7 represents 1 whole, 14 over 7 represents 2 wholes, so a giant 2. And then what is left is 2 sevenths, and 2 sevenths we cannot change in any way to make it smaller, so we can leave it the way that it is. Nothing to change, so I can just rewrite it as such. Let's look at 9/4. 9/4 is going to be, counting by 4s here, 4, and 8. Our denominator stays the same. What would be left if I had 9/4 and I took 8/4 out? Sorry, that was a terrible 8. There would be 1/4 left. Okay, so now we can take 8/4 and we can turn it into a whole number. 8/4 is double 4/4, which means 2 wholes. 4/4 is 1 whole, and 8/4 is 2 wholes. All right, and what is left? We've used this. What's left is 1/4. There is no need to simplify that any further. That is our answer. So I can rewrite it here.